Great. Good morning, everyone. Oop, probably shouldn't stand in the front of that mic with this mic. Welcome to Authenticate. This is our first session. I think people are going to be trickling in. Get registered, get some breakfast, and come on in. So I'm hoping it'll fill up a little, but we'll see. So I'm David Turner. I'm the Senior Director of Senior Technical Director, at the FIDO Alliance. And so this morning I'm going to be talking about Passkeys, mostly at an introductory level, with the goal to set the context for many of the presentations you're going to be seeing for the rest of the week. Touching on some of the terms you'll hear, putting the term Passkey itself into context so that, again, you've got a sense of what people are meaning when they say Passkey, because the term gets used in a variety of different ways, and so my goal is to help clarify that, and as well to show you some of the newer capabilities that are being used with Passkeys that some of you may not be familiar with, because some of them are still just rolling out and just getting fine-tuned. Oops, forward button. So I'm not going to spend a huge amount of time on all of these numbers. I'm pretty sure most of you here are aware of the challenges associated with passwords and bad passwords, and even using things like one-time passwords over SMS. Pardon me. And they're just bad. There's breaches all over the place. There's losses of revenue and income. There's identity fraud. All of these things. Layering in many cases doesn't work well, because the things that people are adding on are still phishable, so you don't really get ahead of where you were. And I'll actually be showing what that looks like later. Generative AI, that's just making things worse in a couple of ways. One is that they become more sophisticated. The language becomes better. They can write the phishing emails and such in a way that looks more realistic. A lot of the challenges, or a lot of the issues today, is the language used is awkward and not what a native speaker might say. They can be clumsy. But on top of that, what we're finding is that the use of AI allows them to gather data from disparate sources related to you to combine into some kind of phishing attack that looks more compelling to you. And I use an example that I dealt with directly. We recently hired a new director of marketing. Her name was Sarah. Some of you may meet her or see her around here. And within a day or so, she sent me a text saying that Andrew, who's our CEO, executive director, was asking her to do something which included a link. So, of course, you're a brand new employee, you don't really necessarily know how things work just yet, and so her inclination was, well, this seems real, but luckily she checked with me first and says, is this real? And I knew Andrew wouldn't do that. That's not his pattern, but of course she wouldn't know that yet. And so we determined it was fake. And when we thought it through, what we realized was that on LinkedIn, she had posted she got a new job. She was working for the FIDO Alliance. So they were then able to go get the name of the executive director. And so they composed this very simple text that combined these little bits of information to produce something that was, reasonably believable. It's going to get worse. Right? They're going to have more data available. They can put it in better context. With more digging, they may even be able to come up with a more specific request. So the whole point is this is just getting worse and worse. And so the need for strong protection to protect against phishing attacks and so on is even more critical than it's ever been. So what we're looking at is a fundamental shift from what we've been doing in the past, which was a password and something else, to a factor that's simpler and easier to use. And if phishing is the primary threat, and what we're looking at here are the large-scale attacks. The attack where somebody comes up to an individual person and threatens them bodily harm to give their PIN, that's not what we're trying to protect against. That's a different kind of problem. What we're looking at are those large-scale, remote attacks where phishing attackers can send out thousands or even millions of emails to people, hoping for, if they get 1% on a million or 0.5% on a million, that's successful. So the idea is to try and stop those kinds of very large scale and especially remote type attacks. So what we're looking at is either a single factor or multiple factors that provide higher levels of phishing resistance and protection to the user than what we've had in the past. So historically, this is the goal that FIDO has had from the very beginning. There's been two-factor authentication options for many years. Some of them actually still worked really well. You had smart cards and PIV cards in the government and so on, and these were very effective ways of doing it, but they had the problem of higher costs and lower usability. Then, of course, you have things like one-time passwords sent over SMS, which are a little easier, but they have the problem, of course, that they're phishable. So our goal was to come up with a model that required just a single gesture. It was generally possession-based, so it was something that was in the hands of the user, which helps protects against remote types of attacks, because in order to authenticate, you got to have the thing with you, and of course, being phishing resistant. And this has been our goal from the beginning, and it's still the fundamental basis on which we've built everything since we started. So I'm going to walk through the model of how FIDO works. The original model looks like this. You had an end user. They interacted directly with the relying party. What's happening with FIDO is we've introduced a thing called an authenticator. And the role of the authenticator is to be essentially the intermediary between you, and the relying party. Drank my Coke too fast. And what happens is when you first want to register with a particular relying party, with a particular account, we create a pair of keys. We create a private key, which is owned and managed by the authenticator and protected by the authenticator. And then we create a public key that is sent to the relying party. And the important thing here is that the combination of the authenticator and the keys, the relying party and the user identity are all bound as a single unit, you might say. And what that means is that if I have, say, 2 Google accounts, I will have 2 distinct key pairs. So you use different key pairs for every combination of the user and relying party. So once you've got the key pairs from the registration, I'm sorry, jumped ahead of myself. One of the important parts of FIDO as well is that it requires user interaction. And again, this goes back to the notion that by having a human, warm-blooded person actually have to interact, that helps protect against certain types of remote attacks. So you've got user presence, user verification, which help make sure that you can't have just generic software attacks. So even the creation of the key pair for a particular relying party requires some kind of user interaction with the authenticator. And as I said, in some cases, it's just a user presence requirement, maybe touching a ubiquity or a one-span key. Or if it's been required, you might have user verification, which would tie in with the biometric, say on your device, or it might be using a PIN. So that's the setup model. And by the way, I mentioned a single gesture. That's the single gesture that enables the activity. So you're not typing in username, password again. So then we come to the actual authentication step. And the process here is that on the right side, we have the relying party. So once the initiation, the client has said, I need to authenticate, or I want to log in, the relying party sends a challenge, which includes some special bits, nonce, to make sure to help deal with man-in-the-middle attacks later. So the challenge comes to the authenticator, and the authenticator checks a bunch of things. It checks to see if, based on the keys that it's already protecting, does it match the user ID? Does it match the relying party domain that it came from, which is a really, really important one, and I'll talk more about that in a bit. And so it's validating these bits of information. And if they match, then the authenticator will use its private key to sign the response and send back the data to the relying party, who can then use their key to the public key they were given in the first place to test the response to make sure that, yes, that really did come from the private key that was originally created for that particular account. From a terminology standpoint, I've been using the term relying party. If you look at most of the FIDO specs, that's the term that is used, where the the service provider is the relying party, but this can be, in other places it's a service provider. In other cases, it might be the identity provider. All those terms represent the entity that does the authentication in whatever model that you've got. So if you hear the term relying party, it may map to a different term that you use in your own environment. But essentially, it's the identity management piece of a system that does the authentication. So the interesting thing about this model, this picture, is that it has been largely unchanged for over 5 years, right? In fact, literally the same picture, same graphics and everything we've been using for over 5 years. And I emphasize that because what it says is the core protocol for doing this is really well established, it's really well baked, and it's a model that has been working consistently over that period of time. So we haven't had to go in and change any of the core flows. As you'll see in a bit, we've added extra features to enable certain other scenarios and to simplify certain interactions. But ultimately, this is the flow that we originally designed, and it's still the flow that's in place today. So let's look now at your typical man-in-the-middle type of attack. And this helps really emphasize or demonstrate where it is that the key way in which FIDO prevents attacks. So in the traditional world, traditional attack world, users trying to talk to the bank, you get somebody that sits in between, and to the end user, depending on what magic the attacker has used, it's probably going to be some variation on the bank name so that it looks really similar to what they're used to, because of course, most end users aren't looking at detailed URLs when they're getting redirected and clicking on phishing things. And so it's easy to confuse the user to make them think that they're talking to the right place. They send their username and password over. What's the next step? SMS OTP, great. So they get that on their phone and they type it in. Oh, guess what? It gets passed through just like the password did. So that man in the middle, they caught the username, they caught the password, they caught the OTP. They're basically in. You think you've logged in, they've actually logged in, and they now have a level of control of your account to do whatever bad things they want to do. Now, I always say this as well. Any kind of two-factor authentication is better than none. So username, password by itself, bad, 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 right? It's just not the way to go. You always should have at least one extra layer on top of that. So even though, as I showed here, OTP stuff is still phishable, it's still better than not having it at all because it is an extra step. If somebody's doing, say, stuffing attacks, right? So they're not directly in the middle like this. They're just trying to stuff credentials wherever they can to see if they work. Those will be thwarted if you don't have, if you have OTP in place, because they're not in the loop of what's going on. So OTP and any other variations on phishable authentication, still better than nothing. Just want to make that really clear. Of course, not as good as FIDO, but better. So this is the flow that you get when you are using FIDO. So again, users trying to talk to the bank. The bank sends a challenge. In this case, you've got your attacker here in the middle, and they've called themselves bank-secure. So, maybe you deal with KeyBank, and now it says key-secure.com. So people think, great, yeah, that's a more secure version of the KeyBank site. Excellent. So what happens then is the challenge gets passed on. Now, with the way the web works and the way HTTP works, the source of the request, so bank.com versus bank-secure.com, is a really, really important factor. And if you remember back when I was talking about how the key pair is bound to the relying party, it's through this domain, this relying party ID. And so what happens is that because the way HTTP works and it gets redirected, the request no longer comes from bank.com, it actually comes from bank-secure.com. And what happens is the authenticator says, I have no idea what that is. It doesn't recognize a credential from bank-secure.com, and so it just fails, right? It just fails. It's not, To be clear, it's not that the authenticator knows it's coming from a bad actor. It just knows I don't have a credential, and that's how it fails. The important part of here is that in this process, of course, in any flow, the attacker doesn't get access to your private key, and because of the way the mechanism's used, the user doesn't even interact and doesn't have to, there's no risk of the user accidentally leaking information to the attacker. And so because the authentication mechanism failed, the attempt to attack fails as well. Pardon me. And that's, in simplest terms, that's where the anti-phishing mechanisms come into play, when it's a man-in-the-middle type of attack. Did I miss anything? No. So what is it that makes up all of this and makes all of this work? Pardon me, there are two primary specifications. You may have heard people talk about FIDO 2, and that was a way of kind of branding the combination of these two specifications as a kind of a single unit that enables this ecosystem and enables these capabilities. So the first is called WebAuthn, and it's a browser-based API for creating credentials and then getting credentials during the registration and during the certification process. And it's embedded in now all the browsers. I'll show a pretty picture in a minute. And because it's built into the browser, it's not just a JavaScript. If we did all this just in JavaScript, the attacks would be trivial, right? It'd be, even if you had complex code obfuscation, it still would be fairly easy for people to hack into the JavaScript. But by having these APIs embedded into the browsers and into the operating systems themselves, there's a level of security. So all the key signing and so on is done in a more protected space, one that's not vulnerable to scripting attacks. The other specification is the one developed within the FIDO Alliance itself, which is called CTAP, and it's the client to authenticator protocol. And this is the one that defines how does an external key, like a key fob type thing. We've got lots of vendors here selling, and we've got Phaeton, Authenticate, we've got Ubiquity, right? There's a lot of companies out there that make the physical keys. And this is the standard that says it doesn't matter who makes the key, this is how that key talks to the operating system and the browser. And that's a really important part, because what it means is that anybody who wants to use a physical security key for doing authentication can choose from any vendor and know that it's going to work if they've supported this protocol. It also means it creates an abstraction on the other side where it makes it a consistent integration between the CTAP interface and the WebAuthn interfaces. So that standardization means that you've got simple integration and consistent integration on both sides. Here's the pretty picture I talked about. It's everywhere, and it has been for a few years now. And this is really, really important, that it's deeply integrated into all the major operating systems, into all the major browsers. There's even now variations people have built on different flavors of Unix. Wow, I combined Ubuntu with Linux. So on Linux machines, it's even available. And the importance of that, the ubiquity of it, is that a relying party can build a solution using FIDO and not have to worry about whether the platform or their end users' devices are going to be able to do FIDO authentication. Right? This takes that part out of the equation, so that as relying parties and service providers want to go out and start using it, high confidence that a device that a user's using has these capabilities. Clearly, some older devices, that may not be the case, but this has been the case now for, again, 4 or 5 years. And so, that's pushing out the lower end, if you will, of the devices that may or may not have that support. So it's not 100% universal. Again, some of the older devices don't necessarily have it, but for the majority of use cases, like I think it's like 80 or 90% of devices out there now, laptops and tablets and phones, and the major browsers, you can count on those capabilities being there. So, quick walkthrough of kind of the progression of things. So, when we first started, right, the model was actually a clear two-factor thing. You had a physical key, you plugged it in, and used it in conjunction with your password. And that was great, because again, as a second factor, it was unphishable, so it was a great way to do it. It offered the phishing resistance, again, with the single gesture, right? I just had to tap it. Or again, in more secure things, scenarios, you may want to use, say, a PIN or biometric to go with it. And ultimately, it was also a great solution for the use of smart cards, even in higher risk environments. Smart cards, while very effective, tend to be more expensive. They require a much more complex infrastructure. You've got device management, key management that you need to do. None of that exists with FIDO. So FIDO was actually able to provide capabilities sort of going up that risk chain that meant that you didn't have to necessarily use smart cards. There were some downsides. Physical security keys, while still the strongest way to do FIDO, can be inconvenient depending on your audience. If you're, one of these if you're a concierge bank where, you've got customers doing transactions over $1 million a piece, you'll give away security keys without a problem. If you're talking about users at CVS, the pharmacy, yeah, not so much, right? That the costs are too high, and the inconvenience for end users having to worry about a key, where is the key, it was just a non-starter. So it was one of the barriers to getting some of the broader adoption at the consumer level, rather. The next stage in deployment was when the keys were actually created and embedded in your device. So on Windows and Android and iOS, say, the credentials could be created by the OS and saved and protected by the OS on the device, which was great, right? All of a sudden, you didn't need the physical security key, but you still got all the benefits of the FIDO authentication. Challenge there, though, was that what if you lost that device? You lost that device, you lost all your keys, blah, right? Not a good thing. The other challenge is, what if I have two devices? I've got an iPhone, I've got an iPad. Well, in the original model, when it was embedded, what I had to do was, if I'm going to bank.com on the iPhone, I'd have to do a registration to create a FIDO key on the iPhone. Then I go to my iPad to log into that same site. I'd have to create a new passkey on that device in order to log in. So I now have two to worry about. So those are some of the challenges. Now, going back to our diagram, how was that addressed? Well, there we go. A new capability has been added where the private keys, right, which are the part that the user manages and controls the keys with, the user controls the keys with. By providing a synchronizing or backup capability, it addresses those two bigger barriers I talked about. First off, if you can back up your keys, if you have a single device, you lose a single device, you go through an account recovery process, say with Apple, I don't know if any, or Android, I don't know if any of you have done it, but it's pretty powerful. And first off, it's a little scary how much they know about you. That enables them to do this in a trusted way. But there's all sorts of mechanisms they have in place so that you can trust that the process is very, very hard for someone to hack into and take over the account. So anyway, the point is that if you have just an iPhone, you lose the iPhone, you get a new iPhone. They used to call it iCloud Keychain. Now I think it's called Apple Password. Someone confirm that? It's now Apple Password? Yeah. So you do your Apple Password recovery, all of a sudden you get all your keys back. Great. The synchronizing deals with that second problem I mentioned, which is if I create a key on my iPhone for bank.com, I now go to my iPad. Because they get synced automatically, that key that I created on my iPhone is now also available on my iPad. When I go to log into bank.com, the key is there, and the user doesn't have to do anything extra. I'll point out an interesting part is that the unlocking mechanism, so in the step where there's this user verification, that's bound to the device itself. So if you're using a fingerprint, say, on your iPad, you would be using the face recognition, Face ID on your phone. And that's an important aspect because what it means is that the biometric type authentication mechanism never moves between devices. So it's using the localized unlock mechanisms to unlock the key in the context of the particular device that you're using. So this synchronizing has provided a huge benefit to making consumer adoption much, much simpler. So what is a passkey? First off, the passkey is just a password replacement for the most part, or at least at the most basic level. It's a password replacement that is not phishable, largely not phishable. And you can use it to sign in to various services on the web, and you can use it to, it can be synchronized across multiple devices. But it's a lowercase p, it's not owned by any company, so there's not an Apple passkey versus a Windows passkey. Passkeys are passkeys, and it's just a generic noun like you would talk about a password. So if you've heard anything else about it being bound to a particular device, bound to a particular vendor, that's not the case. Now, having said that, some vendors will provide solutions, say in an enterprise environment, where they create a passkey provider that creates and manages the passkeys for you, but they're managing it specifically. The notion of the passkey, the protocols, they're all standardized, but there are going to be solutions where they'll choose to close the boundaries, if you will, so it's only managed by a particular entity. So, keep saying some of these things over and over again. So by the shift to passkeys, and the use of the term passkey came along at about the same time as the synchronization came along, and so that combination has raised the bar for the user experience. What's interesting now is that when we talk about the benefits of passkeys, and if you look at a lot of the banners that are out there, it's no longer just a message about security. Right? That's always an important factor, but in fact, usability has become one of the more important factors. Usability from the standpoint that it's simpler to do, usability from the standpoint that the process isn't confusing to the user, and the login speeds have been shown to be much faster. There are going to be other presentations here from different companies. Google has already published data, and I don't remember the numbers, but it's a measurable, the speed of login is measurably faster. Amazon has published numbers showing that cart abandonment, again, is measurably down. Because I'm sure many of you encountered this. You go to an online store, you start buying stuff, you go to check out, you got to authenticate again. It's like, oh, geez. I haven't logged in a while. Well, where's the password? You go through this whole process, and it's a pain. And what they found that by using passkeys, again, that cart abandonment rate has dropped measurably, which is real income, of course, for online retailers. It says here that it's commonly synchronized, and the keys are commonly synchronized, and in the primary consumer scenarios, that generally will be the case, but it won't always be the case, and the service provider or relying party will be able to make choices about how they want to do things. They may require that only security keys are used, so that the keys are never actually moved across. They're always maintained in the hardware of the key. I described the scenario, say, of an enterprise where they've got a single piece of software they use. That piece of software may be designed so that it doesn't synchronize. So synchronization is not a requirement, it's an option, and it'll be dependent on who creates it. Which gets us to the last point, which is who creates the passkey in a given context? Well, you got your physical security keys. But generally, it's going, again, for the majority of users, it's going to be created by the platform or an OS. But also, there's a big model that's come along where we now have essentially password managers have migrated into the role of what we call passkey providers. And I'll be showing in a minute how that model has been extended to use, the password fill-in model has been extended to passkeys to make it even easier. And this is true today. These products already exist. Apple's doing it, Google's doing it, third parties like Dashlane, 1Password, Bitwarden, they already have browser plugins or OS plugins that enable these capabilities. So, oh, these colors aren't as, not enough contrast in here. I apologize for that. I'm not going to go through this diagram in great detail, but the point here is to highlight where the specs fit in and where vendors can fit in to be what we call the passkey providers. So starting with the specifications, here you see the term user device, this very pale green in the center, and you'll notice that there's the browser as the interface, and so the WebAuthn spec provides that JavaScript link between the relying party and the browser platforms, which then talk to whatever's on the user device. CTAP is used at the top. We refer to those often as roaming authenticators because they can roam from device to device. And you'll see that both for the user device and what we call a proximate device, there's an arrow going between them which shows that CTAP is what's used for integrating the security keys into the OS platform. The two biggest changes, that's the model, again, that's existed for a while. The two biggest changes are first in the middle, there's this box between the two green boxes, and this is demonstrating a thing we've called cross-device authentication, and I'll show a short demo of that in a bit, where it allows let's say I have a key on my one device but not the other. This allows me to use the first device to authenticate using its passkey to the other, and I'll have a short video to show that in a bit. The other one is what we call the syncing passkey providers. This is where other vendors can come into play. They can either plug in directly to the browsers, or they may integrate into the operating system themselves. And this is because of the syncing mechanism below, they'll also plug into these other devices, and that's the flow that allows either the backup or the synchronization. This slide is basically the same, but we put in brand names so that you can get a sense of, as you see companies around here, where do those companies fit into this model? So at the top, we've got a number of different physical key vendors. Again, there's many, many more than that. OneSpan, and I never remember all the names of them. So that top layer is are your physical security keys. On the side, your relying parties, those are just the service providers. And again, that can be banks. You'll notice one of the key ones is PlayStation is there. PlayStation and Sony are now using passkeys for authentication. And then at the bottom, you see a number of the passkey providers that are out there, 1Password, Dashlane, Bitwarden. They came from the password management world. And really, it's not a big leap to think, well, if I'm managing passwords, especially in the autofill model, why can't I do the same with passkeys? So that gives you a sense of kind of where the brand names fit into this model. So, some of the new experiences. One of the first ones, I was just talking about the autofill, is this notion that, well, what if we could provide a passkey autofill so that in many cases, we call it not just a passwordless authentication, but a usernameless authentication. So I go and click in my username field, the browser, or whatever device you're using here, does a check, because it knows the service you're connecting to, it knows who you are, and it will come up with a list of possible passkeys. This is all done without knowledge of the relying party. So this is the browser looking at your machine and saying, for bank.com, these are all the keys that you have. So if I have, two accounts, maybe a business account with bank and a personal account, then this process would pop up not just Fred, but I might call it Fred's business. And so this gives me a chance to, instead of having to type in even my username, just click on the FIDO and automatically sign in with Passkey. About as technical as this spec's going to get, that's based on a couple of changes to the WebAuthn specification. The first is to indicate that the autocomplete is being handled by WebAuthn, and then third line from the bottom here, you see that it says mediation conditional, and that's basically saying if there are keys available, present them to the user. So we've now got an even simpler model than we had before, so that the user doesn't have to be going through these steps, and this is partly how we've been able to make the authentication process even faster than it was before. So cross-device authentication is an interesting one. I'm just going to jump all the way. Sometimes you may hear someone talking about the hybrid flow. That's the term that's been taken out of the CTAP specification because it can be extended in a number of ways in the future. But the idea is that we generally call it cross-device authentication. And this is the notion where if I'm trying to log into a site, say on my laptop, I've already created a key on my phone. There's no syncing between them. Say I'm not using one of those passkey providers. Or say I want to log into a machine that's not mine, right? I don't want to synchronize to the machine. I don't want my credentials left on the machine, but I do want to use my passkey to authenticate. So what happens is that the site I'm trying to log into, say on a laptop, will show this QR code. You scan the QR code with your phone. It then gives you the options that exist on that phone for doing the authentication. It then does the FIDO authentication through a back channel, which was set up using the QR code. And one of the key aspects of this is that in that previous diagram that showed all the pieces, remember it was called the proximate device. And that's because of this flow, where it also requires a Bluetooth connection between the two devices. There's no data actually going over that Bluetooth. This is just a proximity check, right? If those two devices that you're using can see each other using Bluetooth, that means they're generally going to be in the same place. And that helps address some of the phishing attacks that are available with QR codes where you can have remote attacks. Well, if you're doing a remote attack, you can't get the two devices to connect because they're not close enough. But that all happens in the background, and the purpose of the QR code is to, essentially share information so they know how to make these connections. So, how do I get the video to start? Let's see. Did that do it? Yes. So I'm on Kayak here, and I want to continue. You'll notice that by clicking in there, it immediately said use it on another device, shows me the QR code. The handheld device, the phone, reads the QR code, asks if you want to sign in. Yes, you do. And then you come back and you're authenticated. Now, a couple things to highlight with this model. That was weird. No, your screen will not go to blue screen of death when you finish the task. I promise. Okay, I'm just going to sit there for a moment. Two things. One thing to mention, and then talk about kind of the benefit of that, or the what can happen. As I said, because of this cross-device authentication flow, no credentials are left on the laptop that you just used, because the whole process went through a side channel for doing it. Now, that has, if it's a case where, well, yeah, I would like to have a credential on that machine, part of our user experience guidelines is that bank.com would at that point say, hey, do you want to create a passkey on this machine? So it immediately takes the user into that registration flow. Again, this is assuming you're not doing the synchronizing. Into that flow, creates the new passkey on that device, and you're all set for the next time. You don't have to do this flow. The second part, though, is the one I described, where you want to log into somebody else's machine. And you want the security of accessing your own account, but again, you don't want to leave any kind of credentials behind. You don't want to make it so somebody can come to the machine later and be able to steal anything there that you can log in with. So it provides a level of protection for logging into what I'll call anonymous machines or unknown devices. So that actually is a benefit. Say going to a kiosk, right? You can now use your credentials to log into a kiosk temporarily without ever leaving fingerprints or footprints behind that someone could then use later. Of course, you got to remember to log out. But from an authentication standpoint, you're protected. So those are all the slides I had. Let's see if I can get to the, there we go. Now we're at the Q&A part. We've got a few minutes left. Went through this faster than I expected today. Are there any questions? Yeah, right here.
So the fact that the backup and sync mechanism feels like third parties got your private keys. How's that addressed? How are they kept safe?
So the question was, third party, some kind of third party has your keys and is protecting them. How is that safe? Do you use a password manager today?
Oh, yeah.
Okay. Same answer. Okay. Right? You trust them already based on some criteria. It's the same model and the same level. You're going to have the same level of trust with that entity that you did with passwords.
Just the fact that you trust them.
I'm sorry?
Just the fact that you trust them.
I'm just not hearing it. I'm sorry.
It's just the fact that you trust them.
Process? Trust them. Trust, yes. Yes, it's based on trust. And I will say, though, that one of the things that we're working on is, oh, good, we're getting a mic, is a notion of security requirements for certification so that we can set a standard for how do they protect in the sync fabric. Are they using end-to-end encryption? Are they using encryption at rest? These types of things. How strong is the account recovery, right? If it's a username password with OTP to account recover, that's not so good because people can take that path to get your stuff as opposed to the direct attacks. And we're working on the process, but we're actually about to publish our first iteration. The certification program's not ready, but we're actually going to publish a review draft of those security requirements. And our goal is to say, regarding the sync fabric, here is the minimum bar we think any provider should meet in order to protect their users in the right way. So it's not a hard spec, if you will, but we're putting in together guidelines and ultimately certification to help improve customer or consumer confidence. Yeah, could you use the mic, please?
Yeah, hi there. My name's Don Burkini. How are you?
Hi, Don.
Thanks for the information today. Two quick questions. What is the difference between the service provider and the relying party?
Nothing. That's just the entity that you're logging into.
Okay.
As I was saying, that depending on what industry and business you're in, you use a different term, but it's the thing you authenticate to.
So both, because in your diagram, they were on different sides of the flow chart, so I just thought they might be different.
They were?
Yeah, I thought there was a service provider in one of the early slides. You had the relying party probably receiving a challenge from the service provider.
That's probably just bad. In this slide?
No, earlier.
Really?
It was my first note, so it's early on.
Oh, okay.
Oh, there.
Yes.
Service providers on the
Good
right
point.
there is, huh?
Yes, good point. Inconsistent slides.
Oh, okay. Good. And the second question, real quick. With Bluetooth proximity validation,
Yes.
do they have to be Bluetooth synchronized, those two devices?
No. In fact, it's interesting. When that interface was being developed, the first thought was use Bluetooth as the channel. The problem was the pairing, right? And getting the devices to recognize each other, not lose connection it was a mess.
Right. Pairings are always a problem.
Oh, yeah. And so that's why it was dropped down to use it for proximity.
Got perfect.
And that's it.
Perfect. Thank you so much.
You're welcome. If you can come up to the mic, that would be helpful. Thanks.
I know there's two questions in the chat. I don't know if anybody has
Oh,
to
I'm sorry.
moderate those
I
or
forgot
not.
to check the chat. I appreciate
That's okay.
it.
So I can share with you.
Yes,
what they are.
please.
Okay, so the first one, a gentleman asked, as per my understanding, the keys are device-based, but on a Mac, if I create a passkey using Chrome, it will not work in Safari. Can you help me understand this limitation?
So I'm going to use that famous should word. If you're on iOS or Mac OS, when you create a passkey in Chrome or in Safari, they should be getting stored at the OS level so that they should be available to both. I will say that some of this stuff is in flux as they're trying to refine. And in fact, I got to give all three platform vendors a lot of credit here. They're working together to try and provide the most consistent UI they can across it, barring branding issues, right? That's always, and their own, Apple always wants to do it one way, Android does another, so those will always create some variations, but for this sort of behavior, the goal is to make that as universal as possible.
Okay, I'll assume you answered the person's question. The other one was, we understand that there can be passkeys can be stored on a device or synchronized. Is it possible for a relying party to indicate that a passkey should not be synchronized?
So there's an interesting approach to how keys get created within FIDO. The process of creating keys in FIDO. When the key is created in the registration process, there are some things that the relying party can ask for, but they don't get an answer until the key has been presented and they get the answer back. And this has been an issue that's been debated for a long, long time. The ideal case would be I ask to create a key with parameters, and if I can't do it, I fail right away. As opposed to I actually create the keys, and then the relying party has to figure out what to do, partly because it's not a great user experience, right? The user experience thinks, oh, I'm all done, and then the relying party goes, oh, no, that didn't work, we got to do something else. Or we're not going to let you in, or whatever it happens to be. The short answer for why we don't work the first way is it had to do with privacy issues, because relying parties could then just start pinging people like crazy, start learning about the device capabilities, and that sort of thing. And again, it's been debated. Every time there's a new version of the WebAuthn spec, this issue comes up, and people talk about it to see if there's a way around it, see if there's a way to solve it. But to some extent, yes, because when you get the key back, there are two flags that have been created to determine if, first, the key is backup eligible, and if the answer is yes, even if it's never been backed up yet, a lot of relying parties will just say, nope. If it could be backed up at some point, don't want it. And then there's another flag that tells you whether or not it has been backed up yet. But if you're looking for exclusion, then generally it's going to be the backup enabled capability that you'll look at. Yep.
Hi, good morning. I guess it's a good segue into my question. So we're talking about probably the strength of the key. When the keys are created, I mean, we have all these vendors and products out here about registration. I guess that gets into setting parameters of attestation, but we don't show that with the big browsers. So when, like, you've been showing a lot of, like, where is the FIDO registration component in here? Like, we're not calling out an actual product, a FIDO certified product. And how do those parameters get set up? How do you force Google to have a set of parameters for your Google workspace?
So I didn't get into that, but there's a whole package of information that is in the request from Google, let's say, to the authenticator that configures the keys. It can pick what crypto algorithms to use, and set some other parameters as well. Like, do you want to? There's a thing called Cred Protect that you can set that says the key. You should never do user verification. It's optional, and then the highest level is it always must have user verification. So there's other parameters like that that can be set to define the behavior of the key.
Is that why you would use one of these FIDO certified products and as a relying party in front of something like Google?
So the certified products that I was talking about are at the end user level. Mm-hmm. The relying parties will have what we call a FIDO server, which they build their own, or they'll purchase from somebody who creates the product. And those we certify as well, primarily from a functional standpoint, to make sure that they support multiple crypto algorithms, so that they are the most general they can be, and they support multiple types of attestation, so that it doesn't really matter whose keys you're using, it doesn't matter whose passkey provider you're using.
Okay, thank you.
You're welcome.
Hi, I wanted to understand more about the cross-device support. Like, how exactly does it work under the sheets? So basically, how does it get synced with the device? Like, Bluetooth is used for proximity, but like you use HTTPS to actually sync the keys, or is it just one-time authentication using
The key is never synced.
Okay.
The key never goes anywhere. The private key still stays locked into the, say, the phone that you're using. What the QR code does is it shares information. It shares information with the phone that tells the phone how to call back to the server.
Okay.
Right, so that's how the phone knows who is that I'm trying to log in with. So it's you've got the one channel connecting to the relying party through your laptop. The QR code passes information like, here's how, here's the beacon you can use to do the Bluetooth connection, but it's also what is the endpoint I need to contact, again, over HTTP, or maybe it's, I think they use HTTP, not WebSockets. But anyway, they connect, and that's just then a normal FIDO authentication. And then the relying party says, great, they authenticated, they flip back to the laptop session, and in the background say, yep, it worked, and they log you in.
Okay, so the challenge is kind of sent from the laptop to, let's say, the phone through the HTTP
The request is made to let's say kayaks, that's what I used. Yeah. Request is made to kayak. Mm-hmm. The QR code is put on the screen. The phone reads the QR code, and what's in the QR code is the Bluetooth stuff, but also the address to contact back at Kayak. Okay. So that I now, if this is my phone, I'm using my phone to do authentication with Kayak in a direct way, just like I would a normal authentication. And then the magic between that working and approving the session is, that's however they want to do it in the background.
Thank you.
Hello. I have a couple of questions. The first one is, so we're showing 3 different options of biometrics, cross-device QR code, and security keys in that Passkey prompt. For some of the corporate companies where biometrics are setting up the cloud network in the computers are not allowed.
I'm sorry, could you speak a little louder? I'm having
so
trouble hearing.
For some of the corporate networks
Yes.
where the biometrics is not supposed to be allowed, or setting up an iCloud is not supposed to be allowed,
Yep.
is there a default way using WebAuthn that we can directly show that cross-device QR code instead of user canceling it and then coming up with a QR code option?
That's an interesting question. No one's asked that before. So essentially what you're saying is, so the ability to choose the authentication mechanism, you can't do at this point. So it's, in general, the unlock, that's what I mean by authentication, right? The verification, user verification mechanism, whether it's PIN or biometric, is generally one you can't choose, partly because the devices themselves don't make the distinction. So on an iPhone, you can unlock the iPhone with a PIN or, say, Face ID. There's no distinction between those.
I'm more referring to a browser. When you go to kayak.com, for example, and you're trying to register it, I'm using it in a corporate computer where nothing is being allowed on a biometrics, but cross-device, I can always create a passkey on my mobile. So how do we show our customers directly a medium that they can create a passkey instead of them canceling it and figuring out that there is a second option?
Oh, yeah, you can't. That clumsy flow is unfortunately how it works.
Okay. The other question, I think the question came around password managers. How do we do in the password managers is exactly as Passkey when they store it, right? My question is not about how encrypted they are, but my question is there any liability discussion happened in FIDO Alliance? Because today we don't ask our customers, hey, you use a password manager, it is their choice. Now, relaying parties are actually saying there is a better way to log in, you register for Passkeys. So are there any liability discussions happen in FIDO Alliance that relaying party should be worried about?
Sorry, did you say liability?
Yes.
So I'm not a lawyer, so I'm not going to answer that part. But I will say that there are a lot of corporate organizations that already use password managers, because you do need to manage passwords often between people and across organizations. And so there is already a high level of trust in some of those. Dashlane, 1Password, LastPass, those are corporate tools, not just end user tools. So they are already, it's not really an answer to your question, just to point out though that there are already products operating at that level. And so I presume they're going to extend the same protection and capabilities to the Passkey world. Okay. I don't think that's a great answer, but.
I'm more interested in terms of, because FIDO Alliance probably be thinking much ahead of all the companies. So I was just wondering, is there any suggestion that you could provide for the new relaying parties who would like to put this before customers, but they're always worried about, we will become liable for these, for the passkeys which are stored in the cloud, which are not handled by relaying
The
parties.
relying party won't be liable for that, if that's what you're asking. Sorry, maybe we can talk later, because I'm not understanding
we
the
can
question.
talk. All right, thanks.
Oh, sorry, I'm seeing big red numbers in front of me. I apologize. We've run out of time. I have to be hard about this because we have sharp deadlines because people are online and they're expecting, I've got 5 minutes before the next one starts. So I can talk to you afterwards with your question. I can't take it right now. So if we could get our next presenters up on stage. Oh, thank you.